Up to this point, there has been no special interest in equations having participants that change in charge. There are many such equations that occur, and it is important to understand their workings. Keeping in mind that balancing equations is an exercise in the law of conservation of matter. A complete accounting of the matter involved in equations is performed during the balancing process. This means that we have to count for all matter, even to the point of counting for electrons. Reactions in which there is a change in the charges of some or all of the reactants are called oxidation reduction or redox reactions. Because there are changes in charge, equations can be considered with the inclusion of electrons showing the movement of electrons from one participant in the reaction to another. The reaction of metallic copper and sulfur is an example of an oxidation-reduction reaction. During the reaction, copper starts as a neutral atom and becomes charged +2. At the same time, sulfur, also a neutral atom on the left, becomes charged -2. Notice that one of the reactants increases in charge from 0 to +2, while the other reactant decreases in charge from 0 to -2. In recognition of the changes in charge of copper and sulfur in this reaction, we can write reactions that indicate these changes. Further, we can write reactions that show the changes separately. Elemental copper will lose 2 electrons to form copper cation, and sulfur will capture 2 electrons to form sulfur anion. These two reactions are referred to as half reactions. Half reactions account for all of the matter involved in the reaction, even showing the movement of the electrons. Notice here that the electrons released from the copper are picked up by the sulfur, as is required by the law of conservation of matter. The copper half reaction is an oxidation reaction, while the sulfur reaction is a reduction reaction. The formal definitions are: oxidation is the result of a loss of electron, and reduction is the result of a gain of electrons. A trick for keeping the terminology straight is to consider that the reduction includes the drop in charge. In sulfur, for example, reduction in charge from 0 to -2. Since the half reactions must be paired, the other reaction, the oxidation reaction, occurs when the charge increases. The point is, if there is a reduction reaction, then there must be an oxidation reaction, and of course, the reverse is true.